Aloha and welcome. In this video, we're going to be talking about historical cryptosystems. So, modern cryptography, it's based on the difficulty of solving mathematical problems. But in the old days, with the old cryptography that used to be used, it was based more on just scrambling letters of the alphabet to hide the meaning of a message that you're trying to send. So, even though the techniques that they used to use, if you were to just use those now, they'd be easily broken, but they form the basis of the modern day systems that we use. So we're going to take a look at some of these. We're going to look at substitution ciphers. We're going to look at transpositional ciphers. So we're going to start out with the substitution cipher. So let's go ahead and open up our textbooks here, and we're going to jump in, and we're going to start with substitution ciphers. Getting a definition. So what is a substitution cipher? Well, a substitution cipher, of which we have two different types that we're talking about here. Um, we're looking at, for example, the monoalphabetic substitution cipher. We're going to be replacing one letter with another fixed letter. So let's say we've got the letter C. We're always going to replace that with the letter X. So you'd have that one-to-one correlation there, the monoalphabetic substitution cipher. And then the polyalphabetic substitution cipher, as you might think, you're going to be replacing that one letter with possibly multiple letters, and it could be like P, T, X, whatever you want to replace it with. So you can have one corresponding to many. So that's substitution ciphers. There's another type of substitution cipher in here called a shift cipher. So in a shift cipher, what you're doing is you're going to take your plain text and you're going to shift it by a certain number of positions. And I have an example here of something like that. So if you take a look at our thing here, we have a wheel, and that wheel has on its outer, on its outer I guess wheel on the outer wheel here, you have letters and you have wheels on the inside as well. So you would take it to begin with, you would line up your, let's say A with A, and you notice that we have a number in there as well. So we line up A with A, and that's going to be, for a ciphertext of zero, a shift of zero. But then if you wanted to actually do a shift and shift it by, let's say, a Caesar cipher, which is three, we could go over here and we would turn the inner wheel, and I'll show you what that looks like in a minute. We would turn it three over, and that would give us the A corresponding with the D here. So you see how let me go ahead and line that up there. So A is shifted over three to line up with the D. So this is essentially the overall is called a shift cipher, but this specific one is called the Caesar cipher. So the Caesar cipher was a shift of three over. But the cipher itself is going to be the number, the shift that you have in there. So that's kind of one of the earlier examples. And Caesar cipher, of course, goes back to the days of Caesar. So we're talking a long time ago. So these, as I said, predate computers. The idea of wanting to hide your messages and send secret messages goes back way back in history. So anyhow, so that's a shift cipher. When you're shifting, by a certain number, Caesar cipher is going to be a shift of 13. We can go down here. It gives an example. I'll let you go through that on your own. Then you've got ROT 13. So ROT 13 stands for rotate 13. So that's one where you're going to do a rotation of 13 instead of 3, like in Caesar cipher, you just be rotating 13. So in this, A is going to correspond with the N in the ciphertext. In ciphertext, again, ciphertext is the text that you come up with. Ciphertext is the hidden message itself. So then you go in here, you do some exercises and answer some of these to figure out if you're working it right. Then we get into transpositional ciphers. So transposition means to when you you're changing. So you're changing positions. So you're changing positions here, or permutations, if you've ever dealt with permutations in math before. So a transposition cipher, a permutation cipher, it's a cipher which reorders the elements of a plain text in the ciphertext without adding or removing elements. So you're just reordering it. And there's different ways here of reordering it. So we're going to look at that. This one right here we're calling a rail fence cipher, and we'll get into that in just a second. But keep in mind that a transposition cipher does not replace an element of plain text in the ciphertext. So that's something key to keep in mind. So an example they give is you can reverse the orders of letters in the plain text in a transposition cipher. So you'd have the word elephant, then you just reverse that, and it's TNAHPELE. Um, so the rail fence cipher is a specific transpositional cipher in which a plain text letters are written diagonally downwards on successive rails of an imaginary fence. So after reaching the bottom rail, plain text letters are then written diagonally upwards on successive rails until reaching the top rail. Then the process continues again down towards the bottom, and it keeps on going until you run out of words there. So the cipher text is read rail by rail from the top rail across down to the bottom rail. And the key of the rail fence cipher is going to be the number of rails that you have. So if you have three, you're going to have one, two, three. You're going to go boom, boom, boom like that, and then back up, and then down again. And then you're going to, when you're actually reading the cipher text, though, you're going to be going across horizontally there. So they they have an example of it right here. I'll get into that in just a second. So in theirs, let's go back to one here. And we're taking the word ransomware, which seems pretty good for what we're doing here. So transposition cipher rearranges a plain text letter to generate a ciphertext. So we're going to be taking ransomware. So notice that it's taking each letter, it's putting it on a different rail here. Notice that our cipher is 3. We're using 3 rails. So it's going down RAN, then it starts going up SO, then down MW, then ARE as we go up again, then down. So when it makes the cipher, though, it's going to take the cipher and it's going to write it across. Okay, so we hit the next. The ciphertext is constructed by placing the letters of each rail next to each other. And then in the end, we'll have the NW over here. So this corresponds to that. So you've got to remember that, and you have to know that your cipher here is going to be 3. So you know that you've got 3 rails, and then you can go ahead and start unpacking all of this. So we have another one over here, the transposition cipher, the columnar cipher. This is a little bit more complex, and it'll take a minute just to grasp here. So I want you to go through this a couple of times, and I'll explain it to you. So a columnar cipher is a transpositional cipher in which a plain text letters are placed in rows of length equal to the cipher's keyword length, and then read in columns to generate the ciphertext. So the alphabetical order of the letters in the cipher's keyword is the order in which the columns are read. Okay, think back through that again. So we're going to set this thing up. We're going to take the plain text letters placed in rows of length equal to the cipher's keyword length, and then read in columns to generate the ciphertext. The alphabetical order of the letters in the cipher's keyword is the order in which the columns are read. Okay, so the example they use here is for if your keyword is run, R-U-N. Since the length of the keyword is 3, the plain text letters are placed in rows of length of 3. So the alphabetic order of the letters in RUN, when you look at it alphabetically, R is going to be the second one. The first one alphabetically is going to be the third one, N. So that'll be the N will correspond to 1. Then you've got R is going to be the second, and then U is the 3. So it's in the order of 2, 3, 1. So and that's going to be because the letter N is followed by the letter R and then the letter U. So the third column's letters are read first, and then the first column's letters, finally the second column's letters. So let's go ahead and look at the example over here. The keyword is kite, K-I-T. So when you look at kite over here, you're going to say, okay, kite, the K over here, that's in terms of what these map out to. We've got the E, that's going to be number 1. We've got the I, that's going to be number 2. K is 3, and then T is 4. But the order of it for us, K is aligns with the third letter here. So we're going to have 3. Then the I is going to be 1. Then the T is going to be 4. And then the E is, wait, hold on, I misspoke there. So the K is 3. And then the I is 2. And then the T is 4. And then the E is 1. So we're going to go ahead and look at that. So, yeah, we take the 3, the 2, the 4, and then the 1. So this is our order that we've come up with here. So now we're going to take our cipher, we're going to take our plain text, the text that we want to actually scramble. So we put that in, and it's going to go in groups of 4. So we've got SPYW, and then on the next line we've got ARE. So now, in order to actually take this and scramble it, we're going to follow in the order that they had up here. So the alphabetical order of the letters in kite is the order in which the columns are going to be read. So we start with the last one here. That's going to give us the W. Then we're going to go, after we've done that one, we're going to go and we're going to take the second row here. That's going to give us the P and the R. Okay, so notice that we go from the W because the W is the one that came first there. Then we're going to go and we're going to take the next one, which is 2 was the second column. So we get PR. So we take those two. And then the one that's the third is going to be the one that corresponds to the K. So that's going to be SA. So we get the SA there. And then we're going to go and hit the fourth one, which is the YE. So that's how you get the ciphertext. So this is rather tricky. You need to sit down and look at it. So you take the keyword itself, you put that, you look at how the keyword is laid out, and then you figure out the order of those characters. So the K is the third one alphabetically. So you've got that is the third one. I is the second one alphabetically, so that's 2. And then the T is 4, and then the E is the first one. So then when you go to take your plain text and to put that in there, you look at what was the first one, W. There's nothing there, so it's just a W. Then you go and you look at the one that's the second, that's the I column. So the P and the R. Then you get the K column. That's why it's columnar. That's why it's the columnar cipher here, okay? So you're going by column. So you get the WPRSAYE. And that is the transpositional cipher. So, yep, so you've got a bunch of questions here to test your knowledge. So go ahead and knock through all that. But the thing to remember, let's go and recap this whole section again. So historical cryptosystems, remember that these predate computers. The basis for this is the basis for modern systems. So we're looking at like substitution ciphers. Substitution ciphers, you've got the monoalphabetical ones where it's 1 for 1, polyalphabetical where it's 1 for many. Then you've got the shift cipher. The shift cipher, it's a substitution cipher because we're replacing them. Remember, we're replacing them, but we're doing a shift of things. So the Caesar cipher is a shift of 3. We've got Rot 13 was the shift of 13. Then we instead of doing up here we're talking about shifts. So we're shifting them over and putting in different characters for it. Over here we're just transposing it. We're just moving them around. So we're changing the order of it. So we've got the transpositional cipher or the permutation cipher. So we've got the rail fence one. So we're doing it around on rails where the number of rails here is our cipher. And then we have down here our last one, which is the transpositional cipher. That's the columnar cipher. And that's the one where we're going to be doing it. We're going to take the keyword and we're going to look at the order of it. And then we're going to take our plain text and go ahead and break that into lines depending on the length of that cipher. And then we're going to go and take the characters that correspond to the order of this. So keep that in mind. That's the main thing. Work through some of these problems. It'll help you get it straight in your mind. And that's it for this section. I will see you in the next section. Aloha.